All right, today we're going to look at slope of a line. Okay, what chapter 2 is going to get into is a lot of things when we talk about some linear situations. We're going to graph, we're going to write equations, we're going to do some stuff with inequalities. But the first piece that we want to talk about is slope and rate of change. They're pretty much the same thing. Rate of change, if we talk about a very common rate of change that you're used to, is miles per hour. Okay, the number of miles that you travel changes, okay, depending on how many hours you drive. And how we look at that with linear situation, what we're looking at is the idea is how does my y change, which again is up and down, as my x changes by some value. Okay, so maybe, if I change my x by 4, what happens to my y? And usually what we'll do is we'll change my x by steps of 1. Okay, so we have out of your book a definition here, a concept that they want us to make sure we understand, and they have it written in a couple ways. Number one, it's a slope, m. Now, remember, anytime we talk about linear equation, you have x's and y's to the first power. You don't have x's and y's to the second power, fifth power, things like that. X and y is to the first power. More often than not, they'll both be there. Occasionally, they may not. But if you see m and you're dealing with that situation, you have to understand. Sorry about that. You have to understand that that represents your slope. Okay. Now, we can only do it if that line is not vertical. Okay. Vertical means, again, up and down. And we'll see in a little bit why that is. So we talk about it as a ratio. Ratio is a fraction, okay, of my vertical change. So how I'm going to move up and down, which a long time ago you're told it was called your rise, over your horizontal change, left and right, which is our run. Now, what we have to understand is that up and down, we have to get better with understanding that's my y change, left and right's my x changes. Now, I have two different formulas up here. You should recognize them. Okay, book uses y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I use the other way. Either way, it'll get you to the same point. Okay. One of the things you have to do is understand that, hey, notice that the ordered pair, x1, y1, they're going to be together, have to kind of stack on top of each other or both come first. Okay, and the other pair has to stack or both come second. They can't be mixed. One of the common mistakes is that somebody will put an ordered pair in that diagonal there, and that'll really goof us up. Okay, so we want to make sure that we stack them up correctly. The reason I use 1 minus 2 is as you get better with these, you're going to go left to right when you read again. And I always talk about more as my first y minus my second y. Okay, I don't even deal with the subscripts. What I look at is y sub 1 is, hey, that's my first y. Okay. So next piece is that we have 4 types of slopes that we're going to run into. Okay, we have what's called positive slope, okay, which is when my line is rising as I move from left to right. Again, we read from left to right, so we're going to talk about my graph as I go from left to right. Okay, we have a negative slope, meaning it's going to fall as we go from left to right. Now, what's going on in those situations? Positive slope means that both my variables are doing the same thing. So for instance, if I'm on my line here and I'm going to go over to this second point, okay, if I move in the y direction, it means I got to go up. Okay, positive y change is going up. And if I go to the right, that's a positive x change. So they're both getting bigger. Okay? But if I want the other direction, now going down, that's the negative y direction. Going left, that's the negative x direction. Both are doing the same thing. And we do the same thing with the negative slope. We can look at it that way. What's going on is both variables are doing the opposite thing. One's getting bigger, one's getting smaller. So again, if I go from this point to this point, if I'm going this way, my y's are going down, so it's getting negative. My x's are going right, so it's positive. Opposite things. Go the other direction. I'm going up, which is a positive y, left, which is a negative x. Opposite things. The other two are situations that we kind of struggle with from time to time. Okay, the idea of a zero slope and an undefined slope. Zero slope is when we have a horizontal line. Okay, what's going on is as x changes, okay, y remains unchanged. Okay, so when x is 4, if y is 7, and then I move to x is 5, y is still going to be 7. Okay, it's constant, doesn't change. Okay, when we get to this undefined slope, this vertical line, Okay, that's why we're gonna look at that with the equation or the formula here in a second, and why we can't talk about that as the slope formula suggested. Okay. All right. So if we look at examples, okay, I'm going to do this one over here on the right side. Again, what I'm going to use is this formula. And once I find my slope, then what I'm going to do is describe what my slope looks like, okay, because of what I get as a solution. Okay, now, what I do a lot of times as well, is especially early on when people are first learning how to do this, is I tell them to identify their points. Okay, -1 is my first x, 3 is my first y, 5 is my second x, 8 is my first y. Remember, they go x and then y. And now I'm just going to plug them in. So when I look for y1, I can go in here and y1 is 3. And some people will accidentally use one of those points more than once, so it doesn't hurt to cross it off once you used it. And I always put the minus in there. y2, second y is 8. First x, -1, minus second x, 5. Now, notice again, talked about how the ordered pairs got to be stacked, or both of them are first, or both of them are second. Okay. Now simplify it. 3 minus 8. And again, if you need to use calculator to do that, that's fine. Okay. -1, -5. Now, don't leave it as negative divided by negative, because that becomes positive. That's simpler than saying negative divided by negative. So I have a slope in this case of 5/6, which means it's positive. So therefore, the graph, if I were to plot these points and connect those 2 points with a line, would be rising. Okay. All right. I want you to try that one, the middle one. Pause the video, see what you come up with. All right. So I ended up with -1/2. Now here's a couple things to point out as we're looking at this. Now, remember how I said I always write that minus in there, and here's the reason. A lot of times people will write 0 minus 4 and think it's good, but you got to remember it's your y minus another y. Okay, so it's 0 minus -4. And remember, minus a negative becomes positive. Signs are important here. Okay, then on the bottom, -6 minus 2 becomes -8. Now when I do this again, I like to take the negative and put it in the numerator. I like to assign it to one of my numerators or denominators. That way when I do use it, I know if I'm going to go up or down, left or right with that situation. Also, always look at simplifying. Now, here's something else I found. If I want to kind of estimate, and I'm going to move over to this example, what's going to happen here, what kind of slope I'm going to get. Okay. Now, actually, I'm going to go back to the middle one since we've already done that. If I look at what happens with my x values, from -6 to 2, I increased. From 0 to -4, I decreased. Okay, if I look at that before I start, then I know I can expect, or I should get something with a negative slope. If I go over here to this first example we looked at, -1 to 5, that got bigger. 3 to 8, that got bigger. Okay, so that's the situation. You can check ahead of time what type of slope we should get, and then when you work it out, you'll have an idea, hopefully, if we did it correctly. Now, negative slope means we're falling. All right, do this first example quick. All right, so I set it up. I get 0 over -8, which is 0, which means I have that situation where I have a horizontal line. Now, look at the other thing. Okay, if I would have done that stuff ahead of time, -5 to 3, I got bigger. But now 1 to 1, my y stayed the same. My y stays the same. I can save myself some work if I recognize, hey, my y is staying the same. That means I got a 0 slope. It means I have a horizontal line. All right, last thing. Okay. Talk about parallel and perpendicular lines. Parallel lines are 2 lines that never intersect again. Okay, and think about it this way. If I have 2 cars that are a certain distance apart and they're both traveling 60 miles an hour, they're never going to catch up, or they're never going to farther apart. Okay, so same rate of change, same slope. That's what we have in terms of parallel lines. Okay, equal slopes. Okay, perpendicular again are two lines that again intersect to form four right angles. And that's your definition. And again, we notate it with that box in there. Now, if you look at those two lines, this line here is increasing, so it has a positive slope, and this one is decreasing, so it's a negative slope. That's going to be true whenever we deal with perpendicular lines. Okay, we're going to have one that's positive, one that's negative. In fact, a lot of times what we look at is this idea. If I know the two slopes, okay, if I multiply them together and get -1, okay, they're perpendicular. This other idea is one, they're going to have opposite signs. So one will be positive, one will be negative. And the second thing is this is the reciprocal, or we flip it. And they talk about in the definition there's your negative reciprocal. But if I take one of my slopes, say for instance 2/3, if I take the opposite of it, so it becomes negative, and flip it, okay, those two lines will be perpendicular. And you can see that if I multiply these together, I'm going to get numerators to get -6, denominators to get +6. I do get -1. So there's a couple ways that sometimes we can recognize that. So what I want you to do again, a little more practice with your slope, is to pause it, find the slope of the line 1, and then slope of line 2. Okay, and then we'll come back and compare. All right, so I started here by looking at what I think was going to happen. My x's got bigger, -2 to +2. My y's got smaller, 8 to -4, so I expected a negative slope down here with my line 1, which I got. When I went to line 2, my x's got bigger, and my y's also got bigger, so I expected a positive slope, which I got. Now, obviously, not parallel because they're not equal. Okay? But two ways we can check to see then if they're perpendicular. I can multiply them. And again, how we've been doing this is we've been multiplying my numerators. -3 divided by my denominator, I get -1. Perpendicular. The other thing, some people just look at, hey, one's positive, one's negative. There's my opposite piece. 3, I could write that as 3/1. And then I have, flipping it, it is 1/3. All right, pause it. Find your slope of line 1, line 2 in the second example, please. All right, so in this case, once I found the line 1 slope, I got 9/5, line 2 is 9/4. So again, not equal. Okay. They're both positive, so I don't have opposites, so there's no way they can be perpendicular, so there's a situation where it's going to become neither. Okay, and that is possible. Now, one of the places we catch you from time to time is if I give you a situation where the slope of line 1 equals 3 and the slope of line 2 equals 1/3. Okay. Not equal, not parallel. Okay. Now, people think because they're reciprocals that they're perpendicular, but they're not opposites. Therefore, they're not perpendicular. So be careful with that situation as well. All right, good luck with all this.